Okay, this problem is a distance, rate, time problem, but it is a little bit more tricky than some of the ones we've done. So it says airplane A travels 2,800 kilometers at a certain speed. Plane B travels 2,000 kilometers at a speed 50 kilometers per hour faster than plane A in 3 hours less time. Find the speed of each plane. So I'm going to walk you through it here. We have the distance for the first plane is 2,800, distance for the second plane is 2,000. The rate for the first plane I'm going to label as my r, and since the second plane was faster by 50 kilometers per hour, I'm going to do r plus 50 for the rate of the second plane. For the rate of the first plane, I'm going to put t, and since plane B was 3 hours 3 hours faster, so 3 hours less time, it was t minus 3. So with this one, we know that distance is always equal to rate times time. Sometimes we want to switch that formula around though a little bit, and in my case I solved for t. So since distance is equal to rate times time, to get the t alone I could divide both sides by r, so that tells me that time is equal to distance divided by rate. So I'm going to do that with each of these rows. For plane A, this row I'm going to take the time is equal to the distance, 2,800, divided by the rate r. And also for this plane B row, I'm going to take the time, t minus 3, and set it equal to the distance divided by its rate. Then what I'm going to do here, and this is what's different than some of the problems we've already done, with a lot of the problems we've already done, we had two values that were equal to each other, so we could set them equal. In this one we didn't. Every single value was different. But we can solve by using substitution, because this is really just a system of two equations. With two equations and two variables we don't know, we want to get it down to one equation, one variable that we don't know. So since t was already solved for in the first equation, I substituted that in the t spot of the second equation, and that's what this here is going to look like. Now we have this one equation with one variable in it, just has a variable r. Now we can solve for r, so that's what I'm going to do up here. First, by clearing the denominators, by multiplying through by the LCD. So if you do that, on this first fraction, the r's will cancel, so you'll just be left with r plus 50 times 2,800. Second fraction, nothing will cancel, so you're just left with 3 times the r plus 50. You have that minus there. Then on the other side of the equal sign, the r plus 50's cancel, and you're just left with the r times the 2,000. So it looks like that. Then from this step I'm at to the next one, I just distributed some things through. I moved the 2,000r, I subtracted that to move it to the other side of the equal sign so we could get it equal to 0 over here. Then I combined some like terms, and that left me at this step. At this step you can either try to factor, which took me actually a couple tries before I got it right, or you could use quadratic formula, because quadratic formula is always a great method to solving quadratic equations. Whether it will factor or not, actually, quadratic formula will always work. So I finally found out how it factored, but if it wouldn't factor, we could then obviously use quadratic formula. This did factor, so then you set each factor equal to 0. I had to throw this one out since it was negative, and speed cannot be negative, so r turned out being 350. So remember, that was the rate of plane A, so plane A is 350, that makes plane B 50 faster than that makes plane B 400.